Hi, my name is Ezequiel Armenta Lechuga, and I'm going to present the oral exam evidence 2. First of all, suppose you're going to use a chromatography for the separation of beta-carotene. Well, the first thing we gotta do is to create a running protocol at a smaller size. For example, using the column chromatography, we can generate a smaller size of the purification process. And since the superficial velocity is supposed to remain constant, and it is assumed that the gradient and particle size do not change when scaling up, we can use the equation above depending on the amount of production that we want. Now, to go into the next step, once there is another version that works and we know the scale factor, we need to obtain the size of the column using the next equation below to know the length of the column once we have the diameters. Once the dimension of the bigger columns is established, we need a stationary phase, so we can use silica gel for this. Then we adjust flow rate based on the column diameter, and we must determine the maximum loading capacity so that we can dissolve crude beta-carotene in the model phase, or a compatible non-polar solvent like acetone. So we can use a liquid loading or dry load that is absorbed on silica for a better separation. On the question 2, what strategies will you use to monitor the process of beta-carotene purification to ensure the minimal required purity? There are two methods that stand out. One, in determining if the compound that we are purifying is the one that we wanted, and the other is the best option to determine the quantity and purity. The first one is the UV-Vis spectrophotometry, a rapid, non-destructive, and cost-effective monitoring way to identify beta-carotene peaks in real time and estimate its purity. And the HPLC, that offers a high resolution sensitivity and reproductive, making it the most accurate method to determine purity with the next formula that is above. Now, into the question 3, how would scale up a ultrafiltration process for the purification and concentration of a green fluorescent protein? Before ultrafiltration, the solution containing green fluorescent protein of GFP must be clarified to remove cell debris and other insoluble materials. This is typically achieved through centrifugation or microfiltration using a 0.45 micrometers filter, since the GFP has a molecular weight of approximately 27 kilodaltons. It is also important to ensure that the GFP is fully soluble in a suitable buffer, such as phosphate or trees at a neutral pH to prevent aggregation or loss during filtration. A key step in ultrafiltration is selecting a membrane with the appropriate molecular weight cutoff, or MWCU. For GFP, membranes with a MWCO between 10 and 30 kilodaltons can be used, but it should have a low protein binding properties to minimize product loss. We can use tangential flow filtration system to extract the GFP, and after this, we just need to collect the retentate. One thing that must be considered is that the entire process should be carried out on controlled temperatures and pH so that GFP maintains integrity. Thanks.